Hey everybody, good morning. I know Mindful, what's up with that, right? I mean, I think they've had some ridiculous platform growth recently here with all this interest in retail investing, or essentially retail gambling at this point. But they blocked a bunch of people out from trading. But you know, the big guys got to win, right? Hold Dre. Uh, yeah, I will not give any financial advice, but I took a strike for the day trading, but that's okay. Uh, yeah, you made 248 in a week. Yeah, that's when it comes down to programming and software engineering, there actually is some really interesting stuff we can get into when it comes into ethics and what is the right thing to do if you're the maker of an application and that sort of stuff. So, I can appreciate all their warnings at least. Um, so I don't know if I agree with them blocking trading, but maybe that wasn't even in their court. I don't know if that's something they were, you know, I think they probably up to them because it's different platforms. Each got to make their own decision, but that's okay. That's a whole other fun story. It'll be an ethics seminar later on once we figure out all this how this all worked. All right, so I'm pulling up our stuff from Tuesday. Fire up NetBeans here. Let's see what we got. You guys having a good day so far? So I got a couple people who got the assignment in. Don't forget the quiz is coming up due as well. Breakfast from Mac. Oh, yeah. I mean, what's happening now with Robinhood and these stocks that Wall Street Bets, the subreddit is pumping is it's definitely not investing. It's let's be honest, it is gambling. So, yep. Uncharacteristically productive. That's awesome. That's good to hear. Productive is good. Biggie, I don't know who you're agreeing with. I'm sorry. Let's see what we got here. Did Chapter 8, Part 1. That's right. That's where we left off. We'll open this one up. I have 3 different classes, and I use NetBeans for all of them. Maybe that's just a bad idea. A hat. Oh my goodness. Where is my hat anyway? Can I leave it back in my office? In my bedroom? I've got a couple good hats too. Alright, I can make do with my jacket. Oh yeah, Android Studio. Uh that's quite an application. It's a little heavy sometimes. I'll try this for you here. Uthrav, how's that? This will work, right? It's totally a hat. Got my awesome jacket here. Uh, apparently people are tanking the Robinhood app now in the App Store with reviews. uh, oh boy. All right. Let me make that quiet here so all my messages don't bother. Okay. Oh, nice. Yeah, the having an SSD is huge. Uh, you know, is Robinhood themselves manipulating the market? Are they actually putting in buys ahead of people, or is that whoever they've gotten paid to send trades to? Like, I read something about Citadel gets to see everyone's trades ahead of time, and they're also an investor in GameStop or something like that. But anyway, we should probably get back to writing some code. What do you guys think? So let me close this out. Let me close this one out. All right. So we were having some fun with bank account and our bank account tests and looking at this idea of static variables or static methods. So we did math as fun. We had a static final here just to have some approximate value. And then we had some static methods because you don't need an instance of the class. Oh, it's okay, mindful. Everyone's thinking about it anyway. We're all distracted. So static methods here, they don't need an instance of the class to be created because they don't need any variables. They don't need, each instance of this doesn't have its own set of values that are going to impact what these calculations are. So it's not like the circle class like you might build where each instance of circle would have its own radius and then it could tell you what its circumference was or what its diameter is or its area or those sort of things. So it's a little bit different when we start looking at using static methods because those ones are independent of any instances. Now they still have access to the static fields, right? We were messing around with this math counter just for fun to show you every time you call the method we could increase this math counter. And instance methods and static methods all have access to static values of their class. Okay. So we kept doing our math calculator, we had a lot of fun with that, and then we did bank account, and then we did bank account test. Again, to look at how do we test these things. We're coming back to testing all the time. And eventually, we were able to test the expected account number, which account number was static, and we were just increasing this one by one by one. I wouldn't recommend this. In the real world, you'd probably use some sort of database, right? We're just having fun here with that. We could run our tests, and depending on which order they get created in, this one became account number 6. Man, it's like over my ears. So like the usual echo you get of yourself, it's not happening, and it just sounds really funny right now on my head. All right, and all of our tests passed. So again, this we had this idea we wanted to make sure we had 100% code coverage. So we were checking that if we tried to deposit a negative value, this block of code runs, and we get back what we expected. A regular deposit, we're doing something here. So someone had asked, and it was a good question, when we're doing testing for plane in Project 1, that you can't be testing whether or not you can enable or disable your landing gear unless your plane is at different altitudes. And to get your plane at different altitudes, we had to use the change altitude method. Right? Let me pull this back up here. And so then the question is, well, when I test it, I'm testing both things at that point. Come on, Project 1, let's go. And it's okay, because we're going to have separate tests just for change altitude here. And then we need to use change altitude before we can actually test, enable, and disable to make sure that things happen at the correct altitudes. So it's not purely testing just this method, because we're also using the other one. So the problem is if we have something wrong with change altitude, it can make these tests fail. And, you know, we just have to accept that. Pardon me. Nope, no, I thought I had a sneeze and I didn't want to sneeze on you guys, but it went away. Maybe it'll come back. You have to like look up at the light, right? Isn't that what you're supposed to do? Usually works. Okay, so when we were testing our withdraw, it only really worked if we put money in first. So we did deposit some money when we were testing withdraw to make sure that the balance went down by the correct amount. So we don't have great ways of separating that because both methods affect that same variable, the balance. Yeah, it is a bad feeling when you have to sneeze and you can't. But I think the feeling went away. Never heard about looking up the light if, yeah, if you have an eyelash in your eye. Okay. You know, when your eyelashes, I've heard, are designed to keep things out of your eyes, right? To kind of protect stuff from going into your eyes. But most of the time when you have something in your eye, it's an eyelash. I feel like that's a little bit ironic. There's a free dad joke for you. All right, so let's take a look here. So we did some static stuff. I'm just making sure we're following along. Yes. Okay, so passing objects as arguments. This is good stuff. This is good stuff. Yeah, free dad joke. You're right. Okay, so we've got bank accounts. Let's come back over to where we've got a main method here. And let's make some bank accounts. So we're gonna test using objects in methods. So we talked about this a little bit before, but this is worth doing. So we're gonna have a bank account. We'll call this checking equals a new bank account. And what do we have to give bank account? I totally forgot. Just the owner's name. Okay, owner's name. So sure, I own this one. It's my bank account. And let's deposit a bunch of money. How much money should we put in? Like, about $100. Okay? Sure. So now I've got $100 in here. Now what I can do, right, if we were to make a lot of bank accounts, maybe we want some sort of method that does something with it. Why not, right? We can write some more methods here. So let's write another method. And you might have noticed our main method here is static. This was all along because we never had an instance of Chapter 8, Part 1. We just ran the main method. So I'm going to post all of the code that I write. So I never expect you to copy along as you go. If you like to, and that's useful for you, you're welcome to do it. And shout at me if I'm going too fast, but I will post it all after the fact. So let's okay, here we go. We'll go with this gambling theme. Bank account. So we're going to say, hey, if you want to, that's too many C's there. If you want to give me a bank account, I'm going to call account inside this method. We'll gamble. Okay? Iteration, thank you. All right, so what we can do, let's make a new random. So random equals a new random. And that means, thank you. Yep, we don't know what random is. Yeah, java.util.random. Yes, that one, please. Posture check. Thank you. And you guys are using all the channel points today. That's good. Actually, and my toddler didn't want to sleep in his bed last night, and he was curled up against me, and it almost fell off the bed. So my back is a little sore. Oh, there we go. It's probably also why I'm really tired. I blame him. Okay. We got random, so yeah, your dog. The cats will sometimes want to come in my room at night, but I try and keep the door closed. Excuse me. Sometimes it gets opened. All right, so we are randomly gambling here. So random.next. Remember, next will do a bunch of different things. Like next int gives us a number between 0, right? Yes, between. Oh, does it go negative? I didn't think it was negative. I think this one's only positive. That's okay. So we'll go next int, and let's say, sure, let's put some bounds in here. Let's go up to 2,000 or so. So this should give me 0 to 1,999 because it is exclusive of this value. What website code? Did I miss it? All right. So we got a random value, and so we want to So we'll be between 0. So let's actually go up one more. This way we're going to be between 0 and 2000 inclusive. And then let's take this as our value. So an int value is that. Okay. And then let's take value and we'll subtract 1,000 from it. So we're either above 1,000 or below 1,000. Or, we're above a negative 1,000 or below positive 1,000. So it should give us that range, was the idea here. Right, so if we ended up at 0 with a random value, we're going to be at negative 1,000. If we ended up at 2,000, the max will be at positive 1,000. So we should get a range here. Then we're going to take our account and we'll deposit that. Oh, well, if it's negative, bummer. Okay, so we got to do some checks. That's okay. So we can say if value is less than 0, account dot withdraw. And that's the money to withdraw. Oops. My value. Now, the problem is, though, this isn't working very well, is it? Because now, when we withdraw money, withdraw is supposed to be a positive number. Right? Because we even checked to see if it's less than 0. It doesn't work. So that's not great. Let's try something else. Let's just generate a random number here, and then we'll do another random value. So this is, let's say if random.next int, let's see. How about if we go from 0 to 2, that should give me a 0 or a 1. So if it's a 0, we'll say this is a withdraw. Else it must be a deposit. What do you think? Is that random and fair here? Take account.withdraw, and we'll withdraw the value. Otherwise, we'll take account.deposit, and we'll deposit the value. What do you think? Hey, thanks for throwing your Twitch Prime sub at the Student Scholarship Fund. Appreciate you hanging out. Alrighty. So we're just going to gamble, and maybe we'll add some money. So I should probably put a little bit more in here real quick, because I want to make sure I can actually withdraw it. Okay. So we put some money in, and then we can gamble with our account. So we'll gamble using our checking account. So we probably want to print out our value beforehand. So what I want to do here, I don't have a good way of doing that, and I want to make my class easy to use. So what I want to do is I'm going to add a method here, public a string called toString. So toString is a very common method here, and we're actually going to put in here that we are overriding toString here. We're going to add this little annotation, and we want to say, hey, I want to override, oh, that's a lowercase t, isn't it? Override the base class version of this, my parent class. And you might say, well, Eric, this doesn't inherit from anything. And yeah, you'd be wrong. But that's okay. Remember, every class in Java inherits from object. Hey, an anonymous cheerer. That is amazing. Thanks for sending some bits. That's super cool. I'm pretty excited. We'll pump up that scholarship fund for sure. All right, so we want to get a better implementation of toString. So you know what? Let's comment this out for just a second here. What is it? EC? Nope. Source. Oh, where is it here? There's a insert comment option. Toggle comment. Control/. There we go. Okay, so I'm going to comment it out for a second. Man, you guys are amazing. That's so cool. All right. So we're going to just toString. So we're going to just print out our checking account. Remember, we're going to get a default implementation here. So Java's not going to complain because anything that's an object, you can toString. And when you try and hand it to system.out.println, Java's smart enough to say, oh, you want this as a string because you're printing it out to the console. So we're going to get some garbage. And that's okay. So we'll take a look at what that garbage is. And then we'll fix it. So a radius, sure, 5. We don't want another one. All right, so what we get here, look at this. Chapter 8, Part 1, bank account at 30DAE81. That is the name of the class, right? Inside of its package, right? This is the package we defined. And that's default here. Do you hear crickets? Uh-oh. You setting up a joke here, or did my volume cut out? Here's the class name bank account. And this is, I believe, its memory address. Pretty sure that's what that is. So you get a default implementation because we inherit from object. But the default implementation is no good. So let's actually give our own. So we want to return a string. We're going to return the, we'll say, account name or account owner. And then we'll add in here the owner name. And then we'll add in here, say, balance, $, and then we'll add in my balance. Okay. Oh, sorry. Yeah, every so often Twitch does get a little bit funny, but I'd like to imagine it's not any more finicky than Zoom is, so I don't feel too bad. Let's give that a shot. So now I should get out the account owner and the balance. All right, so some radius value. No, we don't want another. And look at that. We gambled and we lost $577. Oof. That sounds like someone invested in GameStop. Too late, right? Too late into the game, and you lost a bunch. So, but now, anytime we try and print, we're automatically getting this toString. So, what's happening here, right? This is auto magically calling toString. Okay? So, it's the same thing here, right? We could say checking.toString. But that's just redundant at this point, right? toString. Show it's the same thing. Okay? And we'll see what happens this time when we gamble. Maybe we'll make some money. Ooh, we've lost even more. Ouch. That is unfortunate. That is unfortunate. All right. Let's see. I gotta check now, just for fun. All right, cool. Wow, and if you are into meme things, apparently Doggycoin is just skyrocketing. It's a bummer. I sold mine this morning. Oh, I'm definitely making fun of everyone. You sold it. You thought it was a scam. I mean, it is. It is a scam, sweet tea. So it is definitely beyond the realm of investing at this point. So I have strong opinions about the whole system being rigged, but that's okay. It's a scam, but you're up. Yeah. So it's good and it's funny as long as people are making money. As soon as it crashes, everyone's going to get all pissed off. So, you know, just be careful. Just do be careful out there. All right. So that was the toString method. And this gamble here, we're passing an instance of our class. And what's cool is inside of this, we can call all of our methods. So what's happening behind the scenes is we're just passing the reference to a bank account. We're saying, hey, this is where the bank account is in memory. What happens, though, if we wanted to try, we could say, hey, account equals a new bank account. And let's say this one is owned by a hacker. Let's see if we can steal someone's bank account. Yep, we did 1,000 here. 1,001 because we wanted to get between 0 and 1,000 inclusive. Because nextInt does not give you including the max value. Do we have to look at their values? I mean, we could. Let's see. What does Robinhood say? Someone said we have to look at their stock graph. This is educational. This is software, folks. I go skateboarding. And isn't it snowboarding if there's snow? It's not skateboarding. Let's see, you want like their 5-year graph? Boop! Yeah, this looks real legit. Real legit. Okay, through the methods. Let's do it. Let's go back to educational stuff. This does make a good teaching point on ethics, though. We'll get to that. So in our gamble method here, you say, hey, give me a bank account. If we try and steal their bank account and take their money, we're going to take this variable of account. And remember, when you have reference variables, let's draw a picture here. All right. So we have a bank account, ba. Okay. When we make a new bank account in memory, we tell Java, hey, I need a location to store the bank account. Java allocates a bunch of memory for all the things in bank account. Remember, bank account had a balance, it had an owner. What else did we have? Was that it? It might have been it. Oh, an account number. An account number. Right? So it had a double for that, right? So that was a bunch of bytes. It had a string, and it had an integer for these things. So somewhere out in memory, we're allocating space for these here. Now, balance is a double. That's easy. We can just go get whatever, 16 bytes or something like that. I forget. We could go look it up if we cared. String is a reference type. So string actually stored another memory address of like 7234, which over there, somewhere else in memory, is the actual string. ... Integer, we can actually store value. So remember, if you're referencing something, string is not primitive. So when you're referencing something like a string, what is stored in the string variable is another memory address. So somewhere here is like, this is x22 3, this is like x22 3f, and this is like x23 3 5 or something, whatever. Right? And each one of these then stores values. So typically you'd get a bunch of these kind of in a block. It doesn't necessarily have to be, but usually you get them near each other. What's stored inside the string variable is an address to where the actual value of string is stored. Because when you ask Java for a space to store a string, it doesn't know how much space you need. Right? It has no idea if you're storing one letter, if you're storing a name, if you're storing a sentence, if you're storing a paragraph. You could store all of Moby Dick in a string if you wanted. Right? So Java doesn't know. So the string variable it references by storing a different memory address to some other location in memory. Same with bank account. When we ask for a bank account, it says, okay, sure, here's a reference. You know, this is 52FA here. So the bank account variable stores a reference. The reference knows where the actual stuff is in memory. So when you ask Java for your bank account, it says, okay, bank account, tell me where to go look. And the variable says, oh, go look over here, behind the scenes. So when we hand a method like gamble, a bank account, that says gamble, right? When we hand gamble a bank account, we hand it the reference. So using that reference, I can go get balance, I can get owner, I can deposit, I can withdraw, I can do any of the things that I need to do using the bank account. But if I try and make it new, right? Remember what the new keyword does? Remember we say like new bank account? New here tells Java, hey, I want a new thing of this in memory. Right? So it's not going to change anything over here. It's going to go ask Java for some new memory. Okay, so like X, this is like AF23. Sure, I'm just making up addresses here. And then you get a new set of balance, owner, account number over here. So if we try and steal their account and say, okay, I'm going to be the hacker, I'm going to take all your money, right? Is this going to work? All right, so enter a radius. No, we want to be done. So now, when we print out my account, right, I get my $1,000 balance that I started with. We gamble, and when we come back from gamble, my account hasn't changed. Right, because what we did is we took this account and we said, oh, don't point at Eric's checking account over here, where you used to point at this new thing, and then when I call account.do stuff, like withdraw or deposit, it's happening at this new bank account owned by the hacker, not me, and we're done. So it never changes my values. So when you have a reference, you can interact with it, but you can't reassign it. Right? So we can't reassign. Reassign to a new location. So this makes a new one here. A new account doesn't change the original. Original, right? We'll call it that. Okay? Does that make sense? Because we're passing it a reference value, so we're passing by reference. Now, if you're working with ints and doubles and floats and the primitive types, you do get a pass by value. So you get a copy of it. When you have references, you don't get copies, which is a good thing, because if your class had a whole bunch of details and you made a copy of it, then you'd be doing a whole lot of extra work, and then your function wouldn't actually, your method wouldn't actually be able to change anything. You might be sad. So we're going to leave that out. We don't want to do that. We just want to randomly run here and see what happens. Okay, some radius value. No, we don't want another. All right. Oh, we keep losing money. One of these times we got to win, right? I really want to make sure we win. Let's try it again. I don't think I've ever won any money. I guess it means I should stay off of Robinhood. Yep, still going down. Let's try it a couple more times. One of these days we got to get lucky. There we go. We won some money. No win, only lose. Yeah. That would be unfortunate. All right, so that's passing by reference. Now we could, if we wanted, we could return a value. Right now, gamble is void. We could return a reference to bank account. And that's actually what Mr. Gaddis is doing. Look at that in his example. How cool is that? So if we wanted to make an account or change it, we could just return that value, which is cool. So let's do this. Let's do a static bank account. And we'll, I don't know, create new account. Sure, why not? Excuse me. So if you tell me who the owner is, sure, because I need to have that for a method. Owner. I can say, let's make a bank account, new account, equals a new bank account, given the owner name. And then, you know, we are amazing here, and we give out money to people who open accounts. Sorry, Mindful. Are you on Comcast too? It has been like super flaky for me. I've had to reboot my router almost every day. I don't know what's going on with it. New account.deposit. So we're going to give people $100 to open an account with our bank because we want their money and we want to charge them fees for using their money. And then when we're done, we can return the new account. So what returning a bank account does is it returns a reference. Oh, you got Spectrum? I haven't heard too many people complaining about that, but I don't know as many. Oof. So it's amazing, like, how much we depend on the internet, and it's sad when it doesn't work like it's supposed to. So returning a new account, this is going to return the reference. Returns the memory location of the new account. Right? So then we can assign it places here. So instead of having to do this, right, I could say, let's say bank account savings equals create bank account. Create new account. Given Eric. So this method here will return a type of bank account. So I can assign it right to a new variable here. You okay with that? Right, and then talking about toStrings. Okay. This is fun. This is fun. Mr. Gaddis even has a stock class. That's funny. I don't know why it's so funny. It's very timely, right? The gambling method. Yeah, no problem. So we're saying you hand me a reference to an account and we're going to gamble with it. So we're going to generate a number between 0 and 1,000. That'll be how much money we add or subtract, or deposit or withdraw. Then, because I had initially tried to make it negative or positive, and I was going to be, but you can't deposit negative and you can't withdraw negative. So then I had to change something else. More hydration, thank you. So we just said, okay, let's just do a random number between 0 and 2, but not including 2. So it's either 0 or 1. So that should be a 50-50 chance. So sure, if it's 0, let's withdraw money. If it's not 0, we'll deposit money. So that should give us a 50-50 chance of doing a deposit or a withdraw. So we're just randomly adding or subtracting money from the account. That's what this one's for. So this gives us a 50-50 chance of deposit or withdraw. Withdrawal? We're calling it withdraw, but is it a withdrawal at that point? Is that withdrawal? Just sounds funny. Yeah, I'll post all the code too, but yeah, for sure. I think I even have a link if you do !GitHub. Withdrawal. Yeah, can't English today. There's another A in there if you have withdrawal with the withdrawal. Okay. Not important. Spelling doesn't matter. Yeah, thanks, Nightbot and Sweet Tea. Look at that. We got links. Got all the good links here. All right, so we can pass by reference. We can pass by value for our primitive types. Now let's take a look at equals. This is a fun one. So bank account. Let's because you might have more than one account, right? Let's forget bank account. That's okay. Let's just do another value. Let's do, why not? We'll do some stonks. That's fun. Next to Ninja? I hope not. So let's make a stonk class. Okay. So it needs a string for symbol, and it needs, forget name, we'll just do symbol, and then a double for value. Okay, and then we'll make a constructor for my stonks that take a string for symbol and a double for value. Okay, and I'll take my this symbol and I'll assign it the symbol you gave me. Nope. Symbol. There you go. Don't want that import. That was weird. And then we'll take my this value and we'll assign it the value you give me. Okay, so we got a constructor. It takes these values. Then remember, don't do more work than you need to. I'm going to right click and I want to insert code. I want to insert my getters. Boom. Get symbol, get value. Done. Okay, so just a silly little class. It can hold some values. Okay, so if we come back now, and we want to make some stocks, right? So let's have some stonks. We'll call this one GameStop is a new stonk, given GME, and what do we say the value was? It was something crazy today, right? Let's take a look. I'm personally the only one who doesn't. Look at you being all proper. Come on. 410 currently? Oh my goodness. That is insane. I thought we hit the bubble yesterday. Nope. 297. There we go. So it did go up a little bit. 468 for a little while. Oh man, is this real life? And then 297. Sure. Mindful. Yeah, I'm doing it all for the content, right? All right, and then let's make another one for fun. This is GameStop again. Why not? Again, is a new stonk. And let's give it the same values. Why not? And now we want to print, just for fun, does it equal? And then we'll add GameStop equals GameStop again. Uh-oh. I think I might have to put that in parentheses. String. Oh, come on. It doesn't like it. Boolean. Oh, come on. Okay, okay. That's fine. That's fine. We'll add a Boolean variable. R equal. And then let's put in here R equal. Okay. It wouldn't do that automatically for us. We just had to take an extra step to make a variable. ToString or print line is not always the smartest. It tries. So do you think they're going to be equal? If they have the same name and the same value? Should they be equal to each other? Some radius, and we can be done. They don't equal. Well, where would we get this equals method from anyway? Right? GameStop dot equals. Right? Remember, if you hit dot, you get to see all these cool methods. Equals comes from object. Does one object equal another object? Ooh, look at all this. And here's this first part here is kind of gibberish, but here's the key to it. The equals method implements the most discriminating possible equivalence relation on objects. That is, for any non-null reference values x and y, this method returns true if and only if x and y refer to the same object. So if they point to the same location in memory, they'd be equal. But that's not what we want to do, right? We want to say, hey, if your name is the same and your value is the same, you're probably the same thing. So what are we going to do? What can we do about that? Well, let's come implement equals. At override public boolean equals. It equals object other. That sounds right. Okay. That's our override. Ban GameStop. That's fair. That's fair, Snake. Gotta quickly go raise the price of that there. You're gonna ruin all my fun. The scholar. All right, we have banned the word. Okay, I will try not to say it anymore. So, how do I compare if I'm equal now? Oh, well, we want to see if we have the same value and the same symbol. But the problem is, this one is asking about object. That's kind of funny, right? I really want it to be like another stonk. But now it says, hey, that's not an override. So it's weird because the override has to happen at object, at this object level, right? So what we have to do is we have to see, is it even my type? Because right now it takes an object. And an object can be any reference type, right? So we need to find out what the type is here. And you know what? Let's just Google that. Java type of object. It's probably in the text too. Get class. There we go. Get class. Cool. So I can say if other dot get class does not equal, what do I want to say? This dot get class? Return false. Right? I guess we could even say in here, I think we can put stonk in here as a class. So if you're not my type here, using Google like this IT guy uses Google, yeah. So override is, it's just an annotation, so it's not required, but it gives us some nice checking here. And it's saying, hey, I'm intending to do something that my parent class does already. So the object class has an equals method that will compare one object to another already. We want to change that behavior. So if you didn't talk about inheritance in 1500, then this is going to make no sense. Uh-oh. Doesn't like it. Can't find symbol. Did I do it wrong? Do I have to say chapter 8 part 1? Nope. Hang on. Did it wrong. Let's go back to Google. Object.class. That's interesting. That's all right. We'll just go with this. This dot get class. Why not? We'll compare. If it's not the same class, then no good. Done. We'd have to return false. If it is, then I need to treat it as this. So you might not have done this. This is cool. So I'm going to say this is the a stonk, other stonk equals. And now I'm going to cast the object as a type of stonk. I think it's this way, right? Other? So this is saying, hey, force other to become a type of stonk. Treat it that way. Treat it as if it was this. That sounds right. Java cast object as type. Let's see if there's a better way to do it. We'll consult the almighty Java. Google, I mean. Where's a good hit? Stack Overflow? Yeah. Look at that. We like Stack Overflow hits, right? Is it almost like extend class? Well, so everything extends from object. Everything inherits from object directly. Instance of. That's a better. Cast. Interesting. That looks crazy. Yeah, I wouldn't. Ugh. Oh yeah, that's some nasty things. Well, we won't get there. We're okay with this. We'll just treat it this way. So if it's not a stonk, return false. Otherwise, turn it into one, because right now it's an object. And if it's just an object, other dot. Oh, where'd it go? Other dot. All I get here is methods of object, because we're treating it as the parent type. So all I get is these parent type versions. So if I cast it and say, hey, treat it as a type of stonk here, then I can go compare these things. And now you might be tempted to say if other stonk dot, and now I can get at symbol, and I can get at value. Symbol equals this dot symbol. Right? You might say that. And other stonk dot value is equal to this dot value. Return true. All right. I will be very upset with you if you guys do this. Because what is this line here? What is this turning into? Maybe when you say, does this thing equal this? And does this thing equal this? Don't we already have a Boolean value? It's inside of an if. We know it has to be a true or a false here. So don't say, if this thing is true, return true. Right? Forget all that. Just say return. That's it. Right? Because if it's true, I'm going to return true. If it's not true, I'm going to return false. I don't need to say if true, return true, else return false. I can just say return that thing that's either true or false. Right? So save yourself the time, the trouble, the energy, the effort. Save yourself, 2 lines of code. You don't need if, you don't need else. Just if you're already checking if something is true or false, to return a true or false, just return it. Okay? That make sense? Mind blown. Oh, Snake. I appreciate that. I think there's a good emote for that too, right? All right, but now I should be able to compare them. Okay? Now we'll say, do they equal? And what's going to happen? Let me put a breakpoint in here. And I'm going to run this in debug mode. We're going to watch this happen. Groundbreaking. Mindful. We saved 2 lines of code. You're like 75% more efficient now. What? I don't even know what that means. I'm confusing. I'm confused. I'm confusing. Oh, man. Is it doing something? Oh, there we go. Okay. Enter radius. No, we don't want any more. There we go. We got to our line of code. Let's go to our debugger variables. There we go. So let's step into our code. Nope. Why didn't it work? Uh-oh. I broke it. This equal sign didn't do it for us. Parentheses. I don't think it was parentheses. I think the equal sign didn't do it. Let's go back to Google. Java equals equals versus equals method. See if that gets us a hit. First hit. Let's see. Geeks for geeks. Nice. What do we got here? We got a slow loading page. That makes sense. The equality operator. Yeah. That's what we want. No, that doesn't have us righted at all. See this for detail. That's unfortunate. Just equal? Did I name it wrong? No, I think it equals is okay. It wants to generate a missing hashcode method. I don't think that's gonna, let's see. See if it generates. Hashcode. That looks terrible. I don't think that's gonna fix our problem. Hashing is additional special thing. You'll learn more about that in data structures. I don't think that's anything we need to do. Our radius, no. Yep, still not equal. Okay, that's fine. I'm gonna get rid of that. We don't want that one. Do we need, maybe we need one more. Boolean equals stonk other. Let's see if we can do it this way. I'm trying here. Oh yeah, you can do data structures without doing this one here. Uh-oh. Can't find symbol. Oh, that's just other. Let's try that. So in this case, if you know it's the type of stonk, I don't need to do any of this casting, checking class stuff. Let's see. Still not giving us what we want here. That's unfortunate. Okay, let's go back to Google. Override equal operator Java. Temporary operators. Java beginners tutorial. This has got to be good, right? Where's an equals? There we go. Equals. Yeah. Object. It's dot equals. That's annoying. Why isn't it working for us then? It should work. All right, I can cheat. We can just say dot equals. We can use the method, so that's no fun, right? I don't think we need this one either. Let's get rid of that one. I think it'll work. Let's try that. If we use our method, but I wanted to not have to use the method. That's a bummer. Oh, you know what we're about to do for a break. So let's see. Of course, now they equal because we called the right method. You know, why don't we take a break? I'll do some Googling because that should work. I'm probably just doing something wrong. And I think it saves. It's just it didn't call the method for some reason. I don't know. I got to do some more Googling, or maybe open up the textbook and read it a little better. He kind of skims over it. So, all right. Why don't we take a quick break? We'll come back in say 10 minutes, and we can go from there. Break time. Let's say how about 11:13 a.m. That ought to do it. All right, let me put on some more music. Maybe. All right, let me know if it's too loud. Hey! Alright, I think I figured out the problem. So it's just me being dumb and getting confused with different languages. So you just can't in Java. So the double equal sign just always just does the double equals thing. And you can't change that. So my apologies. In other languages, you can make that work better. So that's just my memory being fuzzy. So, right? Well, got to use dot equals here. Okay? But the key here, right, is if we didn't have this defined, that would still work, and it'd be false. So because we get an equals from the object class, right, so if I take a look at my stock here, and I look at equals, I see this one comes from object. And that's going to do the memory reference comparison, and we'll get false. Eventually. There we go, false. So, but if we want to implement it ourselves, right, then we can go do it. Now, at this point, overriding the one that takes an object is a little bit silly, actually, because if it's not going to happen automatically for us, we might as well just write an equals that takes another stock. Right, so I don't know if there's a lot of gain having to check your class and then do this casting thing, because that's a lot of work. So I'm going to say this one the harder way, overrides, and then we'll have an easier way, easier equals, boolean equals stock other. You know what, I'll call it other stock, because then I can copy paste this one line. Then we just need to return true or false, our comparison here. Okay, and what happens is when we go to run it, it's going to say, oh, this is the specific matching one here. That's the one you want. So now let's try it in debug mode. Let's see what we get. Okay, radius, don't calculate another. All right, now we're going to step in. Step in. There we go. And now we get equals. Uh-oh, it went to the override one. That's unfortunate. Why didn't they go to the other one? All right, it didn't go to the other one. That's fine. That's okay. It still eventually will equal here, though. And life is good. And they equal true. Okay, so sorry, I just got mixed up. You have to use the equals method. You might remember doing that with strings, right? Saying string.equals another string. So that's the right way to do it here, using the equals method when we have objects. Don't use the double equal sign. Right, so we'll just objects is bad. It only compares. They are the same object in memory. Does that make sense? Like the same object in memory is this? They point to the same thing. So we could do that if we made another one of these and set it equal to, like assigned it a value. That might work, but other than that, it doesn't. All right. Sorry, my sugar. I haven't had anything with sugar in it. Yeah, here, I can post all this too. Let me fire up the GitHub client in a second. Maybe. Maybe it'll fire up here. Okay, close that one out. Let's see. 2151. Make sure I got the right repo. There we go. This is push that. No, I don't need to save. Come on. Wake up, computer. All right, so I pushed those changes out for you. They should be out there if you want them. All right. We're doing pretty good so far. Let's see, 118. Yeah. Yeah, okay, okay. GME down to 153. Well, I mean, if the retail investor apps block people from buying it, then it's kind of hard for people to drive up the demand. So they're just they're letting the big funds win here, I guess, because they're not blocked. Pretty sure. I'm not bitter. I'm not bitter at all. Don't worry. Not bitter. Okay. So we'll get into one more topic because we've got next week as well to finish up chapter 8 here. So I don't want to push too far. You guys are doing well so far. So we're going to talk about how to make copies of objects. Okay. Pull this up here. Oh my goodness. D12's broken too. You see, this is the plan, right? Right here, see? Can I view his text? That'll work great, I'm sure. Actually, it did. That's impressive. Wow. That's kind of cool. All right, yeah, so next week we also will finish up this chapter here. Excuse me. Yeah, internet is just crazy. All right. So we'll finish up one more topic, and then we'll call it good for the week. Project 1 is coming up due. Get going on that if you haven't started yet. And then we'll finish up the rest of the chapter next week, and we'll get started on our next project as well. Okay? That sounds good. So one last thing we can do here with stonks is, this is the regular constructor. We can make a special thing called a copy constructor, because what happens if I want to make another one of these, stonk, another copy, if I just say it equals 1, right, what am I getting here? I'm getting that alias, right? This is an alias, 2 variables pointed at the same thing in memory. And it doesn't make a copy of anything. It just says, oh, sure, you variable, you pointed that same thing. Okay? So this is no good. Danger, danger. Okay? Usually if you have 2 variables pointed at the same thing, that's a bad sign. Okay? So what we want to do instead is we want to if we want someone to be able to make copies easily, we can write what we'll call a copy constructor. This is the copy constructor. And it says, hey, I'm going to give you a stonk if you give me another one. So if you want to make a copy of a stock, give me one, and I'll make a copy. So I'm going to say my symbol, symbol equals the other's symbol. Now, this might be bad because strings are reference types, but strings are immutable. So I know that the other stock can't change their symbol. So this is okay. So just be careful. Careful copies of reference types. So ideally you'd want to copy all the way down, but strings are special. We don't have to. So strings are safe for this. Others are not. So if we had another reference type inside of here, like so if stock referenced, I don't know, an account or something like that, we'd have to make a copy of the next thing all the way down. But ours is not that tricky. So in value is other, not value. Okay, that's all we do. So now we can make a copy of one because we're taking their values and we're copying them. So now if I want one here, I can do the right way. So the right way, trademark. I have real copy equals, and I call the constructor, and I hand it the other instance. Did I spell it wrong? No? I didn't spell it wrong, did I? What did I do? Did it not compile? Let me just see if it'll build. That's weird. Build. Can't find symbol. Oh, jeez. New keyword. All right, guys, it's time to quit. I'm losing it. Losing it here. Yeah. So a new stock, calling the constructor, needs that new keyword here. Okay. Then we'll have a real copy. Okay. And then we can compare and all the equals. Yeah, good night, exactly. Going back to bed. I give up. No, I got class again in another hour and a half. This Thursdays are nuts. I made a mistake this semester, but that's okay. We couldn't find anybody to do the JSP class, so I was like, I can do it. I got time in the day between 2 other classes. Sure. All right, so the real copy, right, we'll call that copy constructor and make a copy of itself. That's what it's supposed to do. Made a mistake. Your class starts at 1. Yeah, so you don't get a nap either, Snake. All right. So that's the copy constructor. I think we're good for now with that. Don't forget there is a study group today at 4. So if you're able to make it to one of the study groups, hopefully you can make it to more, and they're worthwhile. I'd love to hear your thoughts on that. You can get a bonus point on the quiz when we have the quiz for Chapter 8. Okay? And we should be in pretty good shape from there. So when we end just a little bit early, you guys can practice some of these things. I'll make sure we've got all the code out here. So this is the copy constructor. Right, with some notes. Do please read the textbook. We don't recommend you buy it for no reason at all. And he gets into further things in the book than he does in just the slides. So you're really going to be doing yourself a favor if you actually read the textbook and look at some of his examples. I'm trying to give you some, he'll give you some more, and then we're going to practice them. So you want to, that way you're hearing it once, you're reading it once, reading it twice or something. It'll make your practice a little bit better. Okay? All right, if you guys have questions, thoughts, concerns, let me know. If not, we can call it a day. Get a little bit of time for you guys to work on practicing some of this code. You can play with your own classes, write your own stuff. If you wanted, you could type bank account, and you can make a copy constructor for bank account for fun. You can copy the account number. That's perfectly fine. Just we wouldn't increase the account number. So if we're making a copy, we'd want to keep the same account number and not change it, is all. So just depending on what we're doing, it's going to behave a little bit differently. That's part of the fun. Okay? All right. We will call it a day. You guys take care. We'll see you next Tuesday then, if I don't hear from you before then.